Section 8.4 continued. We're evaluating logarithms. So in the beginning for section 8.4, we did the properties of logarithms. So hopefully you remember that if you have the log of a base of the same number, remember we said that that's equal to a value of 1. And to check, you can do exponential form. So b to the first power equals b, so that checks out. Remember, we also said that the log base b of 1 is always equal to 0 because b to the 0 power is 1 in exponential form, so that also checks out. Now for this next one, if we have the log base b of b to a power, remember we can use our power of logarithms property. So then if we bring this down, we get r times the log base b of b. And remember, we can also simplify that further because the log base b of b is equal to 1. So really this is equal to r when it's the same value. Now let's go back and do some expanding like we did yesterday. So I would take a minute to pause the video, see if you can do this problem on your own, and then unpause it and see if you get the correct answer. So recall that to write a logarithm equation in expanded form, remember we talked about this the other day, you're going to write the log as the sum or difference using the properties of logarithms. And also remember that we don't want any radicals in the final answer and no exponents in the final answer. And don't worry about this part right here. So for this, if we expand this, the first thing I would do is get rid of that radical because when we're expanding, we do not want radicals. So I would rewrite this as the log of xyz over m to the 1/2 power. Now there's a couple different ways we can expand this. We can do a properties of exponents and do x to the 1/2, y to the 1/2, z to the 1/2 over m to the 1/2. Or if you want, you can bring this down first. It doesn't really matter which one you choose. I'm just going to go ahead and bring it down first. If you bring it in front first using your power property, remember to put parentheses for everything that's going to be inside because everything inside is going to get that 1/2. So now we have the log of xyz over m. Now I can still go because anytime I have logs that are being multiplied, I can use my products property, which you add the logs together, or if I have something that's being divided, I can use my quotient property by subtracting the logs. I usually like to do division and then multiplication if I have the division in my problem, so I'm going to do 1/2 times the log of x, y, z, and then minus the log of m because it was in the denominator. And now all of these are being multiplied, which means I can use my power property and separate them using addition. So I get 1/2 times the log of x plus the log of y plus the log of z minus the log of m. And then the last step would be to take this 1/2 and distribute it in front of all my logs. So I get 1/2 the log of x plus 1/2 times the log of y plus 1/2 the log of z minus 1/2 the log of m. Now I don't have any radicals in my final answer, nor do I have any exponents, and all my multiplication and division is gone, so I can circle this as my final answer. And as I said before, another way I could have done this over here, if instead I would have done the 1/2 to all the exponents, such as the log of x to the 1/2, y to the 1/2, z to the 1/2 over m to the 1/2, and then did my properties of exponents. This would be the log of x to the 1/2, y to the 1/2, z to the 1/2 minus the log of m to the 1/2, and then I would use all my properties. So these would be all separated with addition. Anything that has a power goes in front, and when I do all that, I would end up with the same answer here. All right, for the next one, we want to write this log equation as a single logarithmic expression. So remember that when you're writing something as a single logarithmic expression, that means that you're going to simplify from left to right using the properties of logs, And then again, the answer will only have one log in the equation. You shouldn't have more than one. No numbers in front of the log, and no radical or exponential fractions, rational fractions, I should say, um, so that everything that we're going to have, we're going to write back in radical form. So you just have to remember that a rational exponent is something like x to the 2/3, which is really the cube root of x squared. Now, for this problem, if we're writing as a single logarithmic expression, I'm going to use my properties of logs. Usually I like to do things that are inside of parentheses. If I wanted to, I can distribute this 4 to everything, or I can do what's inside the parentheses and then do the 4. It doesn't really matter. I'm going to distribute the 4 first. So I have the log base 5 of y minus 4 log base 5 of r, and then if I'm multiplying by the negative 4 again, it would be minus 8 log 5 of t. And then I'm not finished, because now I want to go ahead and use my properties. I go from left to right. Anything that's being subtracted, we're going to divide then. Now for this, if I do this first one, I have the log of 5 of y being subtracted from this right here. And I guess you know what I should have done first. Before I do that, I always want to take up my powers. So you do your exponents first for the order of operations, so that also would come up first. So I should fix that. So this would be the log of 5 of y minus the log base 5 r to the 4th power minus the log base 5 of t to the 8th power. And notice I didn't take the negative up to the exponent. I left it as a negative in the equation, which is what you're going to want to do. So now for this problem, I can use my quotient property and divide y over r to the 4th power. And then again, I'm subtracting, so it means I'm going to divide again. So now I have the log base 5 of y divided by r to the 4th, all divided by t to the 8th, which is over 1. So remember, when you're dividing two fractions, just to do this off to the side, we have y over r to the 4th. And then if I'm dividing it by t to the 8th over 1, I multiply it by the reciprocal, which gives me y over r to the 4th t to the 5th. So that's what this is equal to. Sorry, that should be t to the 8th power, not 5th. And that would be my solution. Now, that's not the only way I could have done this. I could have also, from the beginning, I could have done what was inside the parentheses first. And if I would have done what's on the inside the parentheses first, I would have gotten the log base 5 of r. And then this would be plus, and I would take the 2 up as an exponent. So plus the log base 5 of t squared. And then I would simplify this by multiplying what I'm taking the log of. And then this number would come up as an exponent. And if I do that, that means both of these have to get the 4th power. And so then I would get the log base 5 of y minus the log base 5 of r to the 4th, t to the 8th, because remember, you doing the properties of exponents, you multiply when you have a power on the outside. And since these are being subtracted, I would use the quotient property, which states that I divide the two. And notice that I end up with the same answer as I did over there, just another way of doing the same problem. So you can choose whatever method you like to do. So the next part to this is that we're going to use the properties of logarithms to evaluate each expression. So now the key is we're not expanding and we're not simplifying, we're evaluating, which means what we're trying to figure out what it's equal to. For instance, let's say I was trying to evaluate 3 to the second power, well, 3 to the second power would be equal to 9. That would be evaluating it. So I need to figure out what these logs are equal to. So using my properties, the first thing I would have to do is bring this up as an exponent, because you always want to do the order of operations, exponents come first. And then the next thing I can do, I know that 2 to the fourth power is 16, so I can write that in and just simplify. And then the next step, if I have two logs that are being subtracted, I can simplify them into one log by dividing the two numbers. And remember that the number that comes first is this number because it's in front of this number here. So order does matter. And then this simplifies into the log base 2 of 8. And then we're not done because we can evaluate this. So to evaluate this, I'm trying to figure out what is it equal to. And remember we said before, when I'm evaluating a logarithm, if it's not base 10, I need to use exponential form to solve. So this would be 2 to what power gives me 8. And so the best way to do this is by getting a common base. I know that 2 to the third power is 8, so then I know that x would be equal to 3. So that means that the log base 2 of 8 is equal to a value of 3, and that would be my solution. Going to the next one, we have the log base 9 of 81 plus 3 times the log base 9 of 1. So for this one, I would first take up that exponent. And of course, 1 to the third power is just 1. So this becomes the log base 9 of 81. And when I'm adding two logs, that means I'm going to multiply those numbers here. So 81 times 1 is just 81. And of course, we're not finished because it didn't say just to simplify this as one log. It said to evaluate. So now I need to figure out what this is equal to. So the 9 to what power gives me 81, and I know 9 squared is 81, so 9x equals 9 squared, so x would be equal to 2, so that means this would be equal to 2, and this would be my solution. So the last one that we have, same thing, we're going to simplify this using my properties, so bringing that up, I get the log of 2 of 8, minus the log base 2 of 2 to the 5th power, which is just 32. And then remember that anytime you are subtracting logs, you're going to be dividing the two numbers. The number in front goes on top, and the number that's second goes underneath. And then we're not finished because we can simplify. 8 over 32 is just 1/4. And now we need to figure out what this is equal to by setting equal to x and putting it in the exponential form. Now remember that what to the power, 2 to what power gives me 4? Well, I know 2 to the second power is 4, but I want it to be in my numerator, not in my denominator. So that means to do that, I would change the exponent from being positive to being negative. So 2 to the negative 2 is the same thing as 1/4, and so that means that x is equal to negative 2, and that means that the log base 2 of 1/4 is equal to negative 2, and that would be my solution. So these are the types of problems that we are going to practice in class. So just make sure you bring this with you and finish your classwork, and we'll do some more of these.